Today, our topic is the measures of dispersion. Measures of dispersion. Now, that can also be called as the measures of dispersion or the variability. Now, what is the portion? That means when we are thinking about the data, the central tendency alone cannot give the complete picture. Sometimes a measure of central tendency uh, alone can be even misleading. Like suppose we have two batsmen, and they are A and B. Now both have the average score of 67, suppose 67. Now batsman A, its score vary from 0 to 100, whereas B, that batsman's score varies from 60 to 70. So when both have the same average, whom would you prefer? Practically, we prefer B, because in that case, we think B is more consistent. So that's why always the measures of central tendency give us the better result. That is not true. That's why the measures of dispersion or the measures of variability has come into mind. Now, when we are thinking about once again about the dispersion, what do you mean by the dispersion? Uh, Practically, dispersions tell us how the observations in a data set vary uh, among themselves. That means when we are thinking about the measures of central tendency, suppose the data are given in that way. Now, when we are thinking about the measures of central tendency, always from the variability portions or from the different portions, we are thinking the central position. Now, in the case of variability or the dispersions, the data sets has been given. But here we are thinking about the divergence, but the diverge is not the calculation. Practically, what is the difference between the below one or the lowest one and the highest one or the high one? So from that position, why dispersion is important? Suppose it should be number one, you can say rigidly defined. It is very much rigidly defined. Now, number two, it is simple to understand. And also easy to interpret. Now, number three, you can think easy to calculate. Number four, you can think uh, easy to further calculation or algebraic treatment. Easy to further algebraic treatment. And moreover, affected, that is the important one, affected as little as possible by the presence of extremely large or small values. That means whatever be the values are, that may be extremely large, extremely small, but less affection is there. Okay. So different measures of dispersion, that is also what is in our syllabus. First one, practically in your syllabus, that is written the variance and the standard deviation. but we have practically in the different measures of dispersion, different measures of dispersion, four topics. Because without the before three topics, we cannot proceed to the last one, that is the variance and standard deviation. The first one is called the range. The second one is called the quartile deviation. Also, it is known as semi interquartile range. Third one is another important term, that is called the mean or the absolute deviation. And the final one is the variance and standard deviation. So we first start from the range. Very easy. The range is practically very easy thing. What is range? According to the term, we can say range means the difference from that portion to another portion. So for any ungrouped data, first of all, for any ungrouped data, the formula is range is equal to the highest value minus the lowest value. We don't have to think anything about that. What is the highest value? What is the lowest value? And for the group data, we have range is equal to upper boundary of the highest class minus the lower boundary of the lowest class. Let us check with some example. Suppose we have a problem based on the mean or median. Okay, the question was like that, obtain, suppose the question was like that, obtain the mean of the systolic blood pressure of any patient, that is suppose given in millimeter or Hg, like that, of 9 workers in a factory. So what are the data given? Suppose 135, then 120, then 116, 119, 121, 125, 132, 136, 124. So there are 9 data. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, when we are thinking about the mean, we are not thinking about the range at first. We are thinking about the mean. So mean means here the data has been given, that is ungrouped. So no problem. Simply we can find out the mean or mu as addition of all the data, and it gives us 1128, and that is divided by the total number of workers or the data or item, and that is 9. So it gives us near about 125.33. So that is the mean. So how we can find out the range? In the case of mean, we have to find out all the data, all the collection, all the data, then summation, then divided. So a range is simply a different thing. As for the ungrouped data, check what is the formula, highest value minus lowest value. So simply when it has been given, we have to find out which one is the lowest value. The lowest value here, that is, we can think 116. 116 is the lowest value. Then which one is our highest value? The highest value is here 136. So that means range is equal to the highest value minus the lowest value. So that one 136 minus 116, or that one is equal to 20 millimeter Hg. So that is our range for the ungrouped data. That means that is very simple to calculate. Now for the group data. For the group data, whatever we have to find out, now upper boundary of the highest class, lower boundary of the lowest class. Let us take another example, like uh, calculation. Suppose a table has been given, and the table is based on the calculation of mean lifetime. Suppose in hours for a frequency distribution. For a frequency distribution of life hours of 80 light bulbs, and the data has been given like that: life hours, then the frequencies, and data has been given 500 to 600, 600 to 700, 700 to 800, 800 to 900, 900 to 1000, and from 1000 to 1100. And the frequency 6, 12, 25, 18, 14, 5, or the total has been given, that is 80. Now if we have to find out the mean lifetime, that means we have to calculate more two way. That is the what should be the median, what should be the mean, what should be the other type of average thing. But range, for range, we have to think about the lower value or lower boundary of the lowest class and upper boundary of the highest class. So which one is the lowest class? Here, our lowest class is that one, 500 to 600. That is our lowest class. And that one is our highest class. So which one is the upper boundary or the highest boundary? So that is the upper boundary of the highest class, that we can say upper boundary. And that one is the lower boundary of the lowest class. So simply our range is 1100 minus 500, or that is simply 600 hours. So that is for our group data, because the classes has been given, that means the group has been given. So in that way we can find out the range. Range means easy to calculate for the dispersion, highest value minus lowest value for the ungrouped data, and for the group data we have to find out the upper boundary of the highest class, then the lower boundary of the lowest class. Then what are the practically merits or demerits of the range? Merits and demerits means what are the advantages and disadvantages of the range. For the multiple type question, there should be some important factors. Number one, the range is the simplest to compute. We can easily compute or calculate and to understand. That is the first one advantage, or we can say the merit. Now, number two, range is very useful as a measure of dispersion, but when the data has been given very small, that means when a small data has been given, the range is very small, the range is very important. Another one thing that you can say, range does not consider the form of the distribution. That means two distributions, suppose two types of data with different shapes, two types of distribution with different shapes, having a completely different nature of variability, might have the same value of range. Suppose we have given two types of data set, data 1 or set 1, suppose 10, 10, 10, 10, 15, 15, 15, 20, 25, 30, 35, 35, suppose 40, 40, 40. That type of data set has been given. Another type of data set has been given, suppose 10, 15, 15, 20, 20, 25, 25, 25, 25, 30, 30, 30, 35, 35, and suppose 40. So if we draw the distribution, it looks like that one type. Suppose that is for the data set 1. Starting we are considering 10, then we have 20, then we have suppose 30, we have suppose 40. So here for 10 we have 1, 2, 3, 1, 1, 0, 4. For 15 we have 3 15s. So 1, 2, 3. Then we have 120. So that is we are drawing here 20. Another one 25. So here 125. 30. So 130 is there. Now 35, 35. Two 35s are there. 1, 2. And 3 40s are there. So that is the first one which looks like that type of distribution. Now for the data set 2, we have 10, 20, 30, then 40. That is for the data set 2. Now how many tens are there? 1. That then 15, there are two 15s. So 1, 2, 20, two 20s are there. Then 25, 25, 25, 25. That means 4 25s are there. Then 30, 30, 30. So 3 30s are there. 35, 35, two 35s, then 41. So if you think about the curve here, it looks like that one. But both have the same range. Both have the same range because 40 is the maximum value, our highest value, lower value is 10 for the dataset 1. For dataset 2, that is the 10, that is the 40. So both have the same range, that is 40 minus 10 or 30. So whatever, that one is the thing, does not consider the form of the distribution. Whatever be the distribution is, range is very important in that case. Okay, last another one thing, that is range is very much affected by the presence of any outlier. Already you know the term outlier, what outlier is. Suppose I am writing a data like that 10, 20, 30, 35, 40, 45, 50, then 5,000. Practically that 5,000 is the outlier because all the data other than 5,000 is near about same. But the 5,000 is quite different from the other items. So here, if we consider the range, the range is becoming 5,000 because that is the maximum or highest value, then minus the lowest value, that is 10. So that is 4,900. But if the outlier is not present, then the range is becoming 50 minus 10 or 40. That is quite different from the 4,940. So range is very much affected by the presence of any outlier.
990 হবে ওটা।
Okay, that's okay. 990, right? Okay, 4,990. But the also the difference is very much affected. So that's why range is very much affected by the presence of any outlier. And that one is called the range. That means the first one topic of the measures of variability.